Greetings, Mr. Sutton here, bringing you the AB Calculus 3-6 Extra Practice Number 3 solutions on derivatives of trigonometric functions. For this problem, we're trying to find the limit as h approaches 0 of this crazy mess. So one of the keys to success on this one is recognizing that this is the limit form of a derivative. There's some function that they just want you to take the derivative of, and this is their way of showing you that. So the function is going to be whatever you're plugging x plus h and x into. In this case, we're doing sine of 2 of x plus h, and we're doing sine of 2x. So sine of 2x is the original function. So to take the derivative of this is either a very quick, painless process if you've done the chain rule, or if you have not done chain rule yet, then you're going to have to use trigonometric identities. If you haven't done chain rule, using trig identities, you can rewrite sine of 2x as 2 sine of x cosine of x. That's the double angle identity for sine of 2x. And now this can be differentiated just using the product rule. So that's going to be u prime v plus uv prime, and I'm going to set up my box and ribbon over here to help me with that. So my two factors, I've got 2 sine of x and cosine of x. The derivatives of those are cosine of x, actually 2 cosine of x, and negative sine of x. Multiplying this out with the ribbon, I've got 2 cosine cosine, so I'll just write 2 cosine squared, minus 2 sine squared. And this does not look like any of the answer choices. So we're going to have to go a little further. I can factor a 2 out of this at the very least. That leaves me with cosine squared of x minus sine squared of x inside. And at this point, you really have to know your trig double angle identities. It turns out that cosine squared minus sine squared of x, that is the same as cosine of 2x. That's one of the 3 cosine of 2x identities. So you can write this as 2 times cosine of 2x. Now, just looking at this format here, probably your best answer choice is going to be D anyway, but knowing that identity really helps you pick it faster. For this problem, we're given this g function with some trig functions in it, and then we've got g prime of pi over 6 that we want to find. Let's find g prime of x in general, though. So just going left to right here, 4 cosine of x, derivative of that would be negative 4 sine of x. And then 2 sine of x, derivative is going to be 2 cosine of x. 1 is a constant, so that derivative is 0. We're not going to bother writing it. At this point, let's plug in pi over 6 to all of this stuff. So let's see here. This is really 30 degrees. Sine of 30, or pi over 6, that's 1/2. So we've got negative 4 times 1/2. And then cosine of pi over 6, that's going to be root 3 over 2, so 2 times root 3 over 2. Going a little bit further, this is negative 2, and over here this is going to be radical 3. So just adding those together, we end up with choice A. For this problem, we're given this g function where g of x equals the limit as h approaches 0 of all of this stuff. And based off of this, we want the instantaneous rate of change of g with respect to x at x equals pi over 3. So you might be thinking you're kind of clever because you might recognize, limit as h approaches 0, this is the limit form of a derivative. So, they're giving us the sine function, and they just want us to take the derivative of that and plug in pi over 3. The good news is you're almost correct. The bad news is you're missing one crucial detail if that's what you did. And that is that the g function is what we are differentiating, and the g function is all of this stuff. The g function is the derivative of sine of x. So that's the first important thing to realize here, is that we're taking the derivative of sine of x, but that's not the end of the story. That's just the function g, which ends up being cosine of x. Now they actually want us to take the instantaneous rate of change, the derivative of g, with respect to x at pi over 3. So we have to actually go one more derivative here. Derivative of cosine of x is going to be negative sine of x. And now if I plug pi over 3 into that, that's going to be negative, let's see here, radical 3 over 2? Yep. Okay, so that's going to be choice A. On this problem, I'm trying to find f prime for this product. Can't really simplify this, so I'm going to use the product rule, u prime v plus uv prime. And let me set up the box and ribbon for this one. So I've got my two factors, radical x, which I will call x to the 1/2, just to make things a little easier in the short term, and then also cosine of x. Derivative of x to the 1/2, that's 1/2 x to the negative 1/2, and then cosine becomes negative sine of x if I take its derivative. Using the ribbon to multiply all this out now, this is going to be, let's see here, 1/2 x to the negative 1/2 times cosine of x. But before I write that out all unsimplified, let me just take a quick look at the answer choices. It looks like all the answer choices were back in radical form, and also there's no negative exponents. So I'm actually going to do some simplifying as I multiply this out. So this right here, this is really 1 over 2 radical x. If I multiply it by cosine, I've got cosine over 2 radical x. That's my first term. That's my uv, or my u prime v. Going the other way now, this is the square root of x and a negative sine of x, so this is going to be negative radical x sine of x. And does that match any of the answer choices? It does not. However, there are a lot of answer choices that have these big fractions in them. So what happens if we merge this into one fraction? To do that, we're going to need a common denominator, which in this case is going to be 2 radical x. So I'm going to have to multiply this term over here by 2 root x over itself. That would give me just 2x sine of x up top. And then I can subtract that from cosine of x. And this is going to be, let's see here, choose this carefully. Answer choice C. D and C are pretty similar, but C is the one where we are subtracting, so that's what we're going with. For this problem, I'm just taking the derivative of tan of x. No tricks here. It's either you just know this derivative or you don't. It's secant squared of x, so that's choice D. On this problem, I want the derivative of cosecant of x. That's just going to be negative cosecant x cotan of x. That's one where you know it or you didn't. And they had a few answer choices here to distract you, but that ends up being choice D. On this problem, below is an attempt to derive the derivative, so these are different words here, of secant of x using the product rule, and x is in the domain of secant of x, great. In which step, if any, does an error first appear? So this is basically we have to check their work. So step 1, they're saying secant of x times cosine of x equals 1. That is a true statement. Secant of x is 1 over cosine of x, so naturally multiplying cosine and its reciprocal should give you 1. So step 1 is good. We can eliminate that. There's nothing wrong there. Next step, step 2, derivative of this product here equals 0. Well, what happened here is we took the derivative of both sides of the equation. Derivative of secant x cosine of x is, well, whatever it is. But over here, derivative of 1, we know the derivative of a constant is 0. So step 2 is also good. So really, it's down to step 3 having a mistake or there not being any mistake at all. Those are the only answer choices left. So step 3, we actually take the derivative using the product rule. So let me set up my box and ribbon here, and this is u prime v plus uv prime that this should come out to here. So I have my factors, secant of x and cosine of x, and now the derivatives of those. Now we know the derivative of secant of x is secant of x tan of x, but in this problem we're trying to derive that derivative. So we can't write out what the derivative actually is just yet. I mean, you can't use the conclusion of a proof in its own proof. So we're just going to write derivative of secant of x, d over dx of secant of x, because this is a true statement, but it's not just revealing what the derivative is at this point. Derivative of cosine we can go ahead and take, though, because we're not trying to prove that. That's negative sine of x. Multiplying this out now using the ribbon, we've got d over dx of secant of x times cosine of x minus secant of x sine of x. And is that what they wrote in step 3? It is. Yep, it's the exact same thing they wrote here, and also we still have this equals 0 on the other side of the equation. So step 3 checks out, and step 4 can't have anything wrong with it because we didn't have an answer choice for that. So then it's going to be choice D, no error. For this calculator-based free response problem, we're given f as a continuous function defined on -3 to 7. We've got a graph of f right here. And g and h are defined by these crazy looking functions. Now, since this is a calculator problem, I have a sneaking suspicion I'm going to need these functions, so I'm going to put them in my y equals. So here's my calculator. I've entered the g function as y1, and the h function is going to be my y2. Now, coming back to this here, we have another function, the n function, defined as n of x equals f of x times g of x. We want to find n prime of negative 1. Since this is a product, we're going to use the product rule. So in general, that would be u prime v plus uv prime. In this case, that's going to be f prime of negative 1 times g of negative 1 plus f of negative 1 times g prime of negative 1. Just using the product rule and plugging things in kind of at the same time. Now I can rewrite this a little bit. I know I'm going to need the calculator for this g function part. But with the f function, I can definitely write that out now. F prime of negative 1, that's the slope of the f graph at x equals negative 1. That's right here, and that looks to be about negative 2. So I can write this first term as negative 2 g of negative 1. And again, I'll figure out g of negative 1 on my calculator. Okay, moving on to the next thing here, f of negative 1. I need to look that up in the graph. That's going to be the y value there. That's 6. So I've got plus 6 times g prime of negative 1. And now the rest of this I'll do on the calculator. So again, on the calculator, I entered g as my y1. Let me quit out of there now. And let me see, I need to do negative 2 times g of negative 1. So I'll do alpha trace, pull up y1, my g function from that menu, and let me plug negative 1 into that. Plus, I need to do 6 times the derivative of g at negative 1. So for that, I'm going to use my derivative function, math 8. So math, option 8. And then, let's see here, we've got d over dx. I'm taking the derivative of g, so I need y1 to go inside that parentheses. So alpha trace y1 again. And I'm plugging in negative 1 there. Press enter and hope for the best. Comes out to about 5.556. For this part of the problem, I'm defining a new function p as the quotient of g of x and 5f of x, and I want to find p prime of 4. So let's first talk about p prime of x. Since I have a quotient here, I should probably use the quotient rule, u prime v minus uv prime over v squared. Let me set up the box and ribbon to help negotiate that. So I've got my numerator, g of x, denominator is 5 times f of x, and then down below I've got the derivatives, g prime of x, and this is going to be 5 f prime of x. Now if I actually plug in 4, let's see what that's going to look like. So I'll just do this inside the box and then I'll throw it all back together over here. So in here, in the upper left, I've got g of 4, which I don't know off the top of my head, so let me do that on the calculator. So to do that on the calculator, since I've got g entered as my y1, I just did alpha trace, pulled up y1, and I'm going to enter 4 into that. And I have a feeling this is going to be a crazy decimal, so I'm going to do myself a solid here, and I'm actually going to store this as a letter constant in my calculator. I'll press the store button, and I'm going to store this as alpha a. So now I don't have to keep redoing this every time I want this decimal. So pressing enter, that's about 3.302 and some change. So I'll just write a approximately equal to all of this stuff. And now I can use a instead of all this stuff whenever I need to. All right, so my next thing I need to do is 5 times f of 4. So 4 on the f graph gives us a return of 3. So this is 5 times 3, which is 15. Next, we have g prime of 4. So let me go back to the calculator now. And I'm going to need to take the derivative of g now at 4. So this would be math 8. So derivative, dx, alpha trace to get y1 and take the derivative of that. And I'm plugging 4 into all of this. And then let me just arrow over here. I'm going to store this as well. I feel like this is also going to be a crazy decimal. Let me store this as alpha b. Enter. And that's about 0.3975, which I'll just approximately equal to b. There we go. And then finally we need 5 times f prime of 4. Well, on the f graph, the slope of this graph at x equals 4 is, let's see, we're going up 1 over 3, so that's 1/3, but we're multiplying that times 5, so that's 5/3. All right, using my ribbon to multiply this all out, I'm going to have a big fraction here for p prime of 4. Up top, I have u prime v, so using my ribbon, that's 15 times b, or b times 15. Going the other way, we're subtracting a times 5/3, and then all that's going to be over 15 squared. Now, since I've defined a and b already, this is one big constant, and if I wanted to, I could leave this unsimplified, but since I have my calculator, let me go ahead and see what this actually comes out to. So here I am back on the calculator. I've got 15b minus 5/3 a, and I used fancy fraction a few times to get these nice little fraction formattings here, so I didn't have to worry about parentheses. I've got 15 squared in the denominator. Let's press enter and hope for the best. That comes out to about 0.002. For this last problem part, they want us to find the value of x on -3 to 1 such that f prime of x equals h prime of x. All right, so I'm eventually going to have to use the calculator, but before I do that, I'm going to need to show the people who are grading this what I'm actually setting up to do on the calculator. Let's start with f prime. So f prime, that's the slope of this graph, and that's going to depend on where you are on the graph. But on the interval from -3 to 1, so that's from here down to here, which is the exact interval that they're talking about here, there's only a single slope. It's down 2 over 1, so that's a slope of -2. So we want h prime to equal -2. There's just one problem. We haven't defined h prime yet. Here's h, though. So I'm just going to take the derivative of this thing and set it equal to 2, and then I can solve for x on my calculator. So h prime, that's going to be -7 sine of x plus 3x squared. And now that I've defined h prime clearly, I can set it equal to -2 and just see where these things intersect on the calculator. So back on the calculator, I've gone into my y equals again, and in y3 now, I'm going to put this h prime function. It looks like I never ended up really using the h function in y2. Oh well. Now I've got this -2, the other half of my equation, entered as y4. And before I graph this, let me deselect these other functions because I don't really have any interest in seeing them on the same graph. Also, before I graph it, let me go to Window, and let me go from -3 to 1, because that's the interval they gave us, so that'll probably give us the best window for seeing what's going on here. And now let me do zoom 0, zoom fit, and hopefully I can see where these two things are intersecting to figure out the magic h value, or x value rather. So there's the first thing, there's my horizontal line, -2. We've got a nice little intersection right here. Let's do second trace, option 5, intersect, and then let me just arrow over with my spider close to that intersection point, press enter, 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 and that comes out to about 0.343. So there it is on the graph, there it is on the paper, and we're calling it a day.